The most important type of variable we'll work with in MATLAB is a vector, and we already talked about the easiest way to make a vector. I call this way the by hand way. You use square brackets, and then I write 1, 2, 6. And that is defined V to be the vector 1, 2, 6, the row vector. 1 row, 3 columns. So say instead of making the vector 1, 2, 6, what if I wanted to make the vector 1, 2, 3, 4 all the way up to 1,000? How could I do that? Well, obviously it's not practical to do it by hand. I can't type out those 1,000 different numbers. But what I could do instead is use one of the built-in ways in MATLAB, and there are lots of them, to make vectors. So there are two that are most important for us. The two are using colon and using something called linspace. And of those, colon is the one that's most important. So let me remind you how to get help. I can type in help colon. And this is going to give me a description. So I can either do J colon K. And what that does is it starts with J and goes up by 1 until it reaches K, or until it's about to go past K. An exact same thing for J colon I colon K. The only difference is that instead of going up by 1 each time, now it goes up by I each time. So maybe that's a little confusing, but if you see some examples, it'll make sense. Say I try to do 1 colon 10. Then that's in the form of the first one, J colon K. There are just 2 numbers listed. And it starts at the first one, goes up by 1 until it gets to the last one. So it's not obvious what will happen if I do something like 1 colon 20.3. And the rule of thumb is that MATLAB is never going to go past the number that I listed. So it's never going to go past 20.3. If it hits it exactly, that's fine, and it'll use that in the vector, but it's never going to go past it. So the one where I use 3 numbers could do 1 colon 2 colon 20.3. And it's the exact same thing. It's never going to go past 20.3, but now instead of going up by 1 each time, it's going up by 2 each time. So 1 plus 2 is 3, plus 2 is 5, and so on. And I could also go in the negative direction. Say I do 1 colon -3 colon -100. So here it has started at 1, then it keeps adding -3, so keeps subtracting 3, and it's never going to go past -100. So if I do the same thing, remember I can get that command by hitting the up arrow. That's a way to get it quickly. If instead of stopping at -100, I tell it to stop at -101, then it actually hits this number, actually hits 101. What if I try to do this same thing with just 2 numbers? What if I do 1 colon -101? What's going to happen? Well, it's going to start at 1, and it's going to try to keep adding 1, and it's going to try to never get past -101. And so that's a problem already at the very beginning, because it's trying to go up. And so that's incompatible with saying never go past -101. Okay, so you might think that it would return 1, but it just doesn't return anything. Returns what it calls an empty row vector. Okay, so that's like saying nothing happened, no outputs. So if I were to do the length of this, so say I do length of this most recent output, length of ANS, it says it's length 0. It's like a vector that doesn't exist. So that was the colon way to make a vector. What about the linspace way? So how do you spell it? You spell it like line space, but without the E, so that's why I pronounce it linspace. And what is this going to be used for? We're going to use it a lot for plotting. And the way it works is instead of telling it what I want the increment to be, how much I want to go up by each time, I tell it how long I want the total vector to be. So we're not going to use this first one so much where it's just 2 inputs. Usually we're going to use this one where it's where does it start, where does it end, and how many inputs. So if I do linspace, how about 1, 10, and 4? So what does it do? It starts at 1, it ends at 10, and then it fills in numbers so that they're equally spaced. So what if I had done linspace 1, 10, 5? What would it look like? And then it looks a little more random, but the key thing is that these are all spaced apart the same amount. In this case, they're all spaced apart 2.25. Okay, so if I want to get from 5.5 to 7.75, that difference is 2.25. I get from one to the other by adding 2.25. And what if I want to use a lot of points? How about 1,000? Well, probably I don't want to look at this. So there I've just created 1,000 numbers. And that's sort of a pain to look at. So let me clear the screen. Okay, I do that by typing CLC. And let me get the command back again that created that big list of numbers. And let me define this vector to be W. And a key way to suppress the output while still defining W is to put a semicolon at the end of the line. So notice that over here in the workspace, there's a variable called ANS, there's a variable called V, but there's no variable called W. Okay, I'm about to evaluate this line that I have written in the command window. There I've evaluated it. And now I do have W in the workspace, even though it didn't print anything. And the key way that I got that was by using this semicolon at the end. So especially when we're writing our own functions, we're going to use this semicolon all the time as a way to not have things printed as these long functions that we're writing are being evaluated.